Good morning, ma'am. Let's talk on the topic of Python Pillow. Python Imaging Library is a free and open source additional library for the Python programming language that adds supports for opening, manipulating, and saving many different images files formats. It's available for Windows, Mac, OS X, and Linux. The latest version of PIL is 1.1.7, was released in September 2009 and supported Python 1.5.2 to 2.7. Let's overview on Python Pillow. In today's digital world, we came across lots of digital images in case we are working with Python programming language. It provides lot of image processing libraries to add image processing capabilities to digital images. Some of the most common image processing libraries are OpenCV, Python Imaging Library, PIL, Scikit-Image, Pillow. However, in this tutorial, we are only focusing on Pillow module and we will try to explore various capabilities of this module. Python Pillow, a fork of Pill. Python Pillow library. Python Pillow, Python Imaging Library expansion of PIL is the de facto image processing package to Python language. It incorporates lightweight image processing tools that aids in editing, creating and saving images. Support for Python imaging libraries got discontinued in 2011, but a project named Pillow forked the original Pill project and added Python 3x support to it. Pillow was announced as a replacement for PIL for future usage. Pillow supports a large number of image file formats including BMP, PNG, JPEG and TIFF. Let's go introduction of Python. Python Pillow. Python Imaging Library is a free and open source additional library for the Python programming language that supports for opening, manipulating and saving many different images files formats. Let's learn some topics in Python Pillow. Image archives, image display, image processing. First one, image archives. The Python imaging library is best suited for image archival and batch processing applications. Python Pillow package can be used for creating thumbnails, converting from one format to another, and print images, etc. This works by image archives. Let's go on image display. We can display images using TK photo image, bitmap image and Windows DIV interface, which can be used with Python Win and other Windows based toolkits and many other graphical users interface toolkits. For debugging purposes, there is a show method to save the image to disk, which calls the external display utility. Let's go on image processing. The Pillow library contains all the basic image processing. Functionally, we can do image resizing, rotation and transformation. Pillow module allows you to pull some statistics data out of image using histogram method, which latter can be used for statistical analysis and automatic constant enhancement. Let's go on Python Pillow using image module. Opening, rotating and displaying on image. For example, for PIL import image. For opening image, use image module, and to show actual image and have to show rotated image. These are the images which is an actual one, and this is the images which is rotated in 45 degrees. This is an rotated image which is 45 degrees. And opening and displaying the image. The Pillow module provides the open and show function to read and display the image respectively. For displaying the image, Pillow first converts the image to a PNG format on Windows OS and stores it in a temporary buffer and the displays it. Therefore, due to the conversion of the image format to PNG, some properties of the original image file format might be lost, like animation. Therefore, it is advised to use this method only for test purposes. Let's find location of the image in Pillow. For Pill import image, let's location of the image img equals to import open parenthesis Greek JPG. The output we can see that Greek for geeks is in the middle one. Getting information about the opened image, getting the size and format of the image. Size attribute provides the size of the image. It returns a tuple that contains width and height. Format attribute return the format of the image file. Let's see another example of location of the image. First, from PIL import image, first we have to locate location of the image, and next I have to give the command for size of the image and next of the format of the image. Right, and the print option is img.format. The output of it is 287,70 JPEG. Let's know about bands. An image can consist one or more bands of data. The Python image library allows you to store several bands in a single image, provided they all have the same dimensions and depth. For example, a PNG image might have R, G, B and A bands for the red, green, blue and alpha transparency values. Many operations act on each band separately. Example, histogram. It is often useful to think of each pixel as having one value per band. And next about the modes. The mode of a image is a string which defines the type and the depth of the pixel in the image. Each pixel uses the full range of the bit depth. So a 1-bit pixel has a range of 0 to 1 and 8-bit pixel has a range of 0 to 255 and so on. Let's move on coordinate system. The Python imaging library uses a Cartesian pixel coordinate system with 0 to 0 in the upper left corner. Note that the coordinates refer to the implied pixel corners. The centers of a pixel addressed as 0 to 0 actually lies at 0.5 to 0.5. Coordinates are usually passed to the library as two tuples x and y. Rectangles are represented as four tuples with the upper left corner gives first. For example, a rectangle covering all of an 800 cross 600 pixel image is written as 0 0 800 600. Let's know about filters. For geometry operations that may map multiple input pixels to a single output pixel, the Python imaging library provides different resembling filters. Pill image nearest. Pick one nearest pixel from the input image. Ignore all other input pixels. Let's know about box. PIL image box. Each pixel of a source image contributes to one pixel of the destination image with I- Identical weights for upscaling is equivalent to nearest. This filter can only be used with the resize and thumbnail methods. New version 3.4 Pill image Billiner Billiner Pill image Billiner. For resize, calculate the output pixel value using linear interpolation on all pixels that may contribute to the output value. For other transformations, linear interpolation over a 2:2 environment in the input image is used. Let's know about BICUBIC. For resize, calculate the output pixel value using cubic interpolation of all pixels that may contribute to the output value. For other transformations, cubic interpolation over a 4x4 environment in the input image is used. And let's know about Lanczos. Calculate the output pixel value using a high quality Lanczos filter. It truncated sync on all pixels that may contribute to the output value. This filter can only be used with the resize and thumbnails methods. Thank you, ma'am.